Corn is one of the most important crops in the world. It can be used as medicine, food, fuel, and feed. Therefore, how to ensure the yield of corn has become one of the problems to be solved urgently. To monitor the growth of corn, we must understand the common growth status of corn. The common growth states of corn are healthy, stress, tiller, non-germinated, and double. Although the seedling with tillers is a normal phenomenon, however, tillers cannot increase the yield, but consume lots of water and nutrients, which affects the growth of main stem. So, this kind of situation needs to be identified. The number of non-germinations is undoubtedly an important factor affecting yield, so we need to reseed in time. In the process of sowing, there will be many seeds placed in one hole, as a result of which double germinations will appear. In general planting mode, the amount of the fertilizer is decided according to single plant standard, so there will be insufficient fertilizer at the site where double germinations appear, which will affect the normal growth of corn. At the same time, double germinations will cause the planting density to be too large, which decreases the plant's lighting and reduces the synthesis of organic matter. Therefore, the occurrence of double plants will reduce the yield. It is necessary to intervene in the early stage of growth and cut off one plant to ensure the health of its surrounding plants. So, the goal of our robots is to identify the 5 states listed above and make corresponding operations for the non-germinations and double germinations, and finally present the status, distribution, and population density on the visual screen and send the data to the server. To deal with the non-germinations and double germinations, we have designed a mechanism to accomplish the mission. Since the release of the rules in November 2019, we have been improving and optimizing the mechanism, and there have been 3 versions of our concept so far. We have used the design of crawler wheels, which can greatly reduce the damage to the soil. The control of the linkage mechanism is relatively simple, which can be directly driven by the servo, but the position of seating is not precise enough. In order to improve the accuracy of seat positioning, we have designed a guide rail chute mechanism that can be positioned in 2 vertical degrees of freedom to enable precise positioning. Taking into account the excessive pressure on the ground and the possible inefficiency of the recognition system that requires real-time feedback, we decided to design the 3rd version of the mechanism, which is also our final one, with an adaptive gear and rack seating mechanism. The precise seating tray can plant single seats through the cooperation of stepping motor and filter, and it is convenient to add seats at any time. The sewing components driven by the gear and the rack can expand the seating area and meet the demand of the users. The plant cutting end effector is a simplification of the axe. The end effector driven by the servo receives a signal from the microprocessor to cut a seedling when the vision system recognizes the double germinations. All states are recognized by visual recognition system. The realization of recognition is divided into 2 steps. The first step is to recognize the target. Due to the random placement of the plants, the accuracy of general identification techniques is low, so we adopt the convolutional neural network to solve this problem. There are 5 types of targets, so the architecture of the convolutional neural network is not very complicated, and it does not take a long time to train this neural network, which consumes less computing power. In order to use this method, we firstly collected a large number of images, including different directions of leaves, different light exposure, etc. Then we manually classified the images into 5 categories and fed them into our model for back propagation training. It was gratifying that our error curve converts perfectly and there was no overfitting problem. In the actual operation process, it can effectively adapt to the environment and has the characteristics of high accuracy and high robustness. The second step is the positioning of the target. When our machine vision system recognizes double germinations and non-germinations, we need more precise positioning. Central mathematic methods are adopted to calculate the coordinates of the central pixel of the recognized object so that the OpenNV can judge when to send information to Arduino, which controls relevant operations. In order to make the robot have functions such as walking, identification, seating, display, and wireless transmission, we chose Arduino as the main control board and used stepping motors, OpenNV, servos, LCD, ESP8266 to support these functions. When the robot works on the field, OpenEnvy will detect every position and transfer the result to Arduino, which controls the hardware to perform corresponding operations on different status and sends information to servers through ESP8266 after the operation is completed. In particular, in our formal design, we plan to transmit the data of OpenEnvy to Arduino through serial communication. However, during the testing process, we found that the serial communication is not accurate, and also it takes up a lot of resources of Arduino, which makes robot's working function appear to be stuck. Therefore, we gave up serial communication and used electric level. We changed the output level of the 3 digital pins of OpenEnvy to represent different germination status, and drew the map as shown in the right side figure. This method effectively avoids transmission errors, and this is the video of our robot. First of all, we check the size of the robot.
3, 2, 1, go.
And we can see the robot can be placed in a cube with a side length of 12 inches. We chose 4 camera positions to show the robot's working process. As you can see, the main screen shows the overall working road of the robot. The lower left corner is a close-up of the LCD. It shows the robots can feedback plant information on the LCD screen in real time. And upper left corner is the GUI that can randomly arrange the status corn plants and automatically calculate time and score. The upper right corner is the tracking angle, which mainly records the showing movement of the robot. When working, the robot moves along the black tracking line. When a non-germination state is recognized, the gear and the rack drive the seating components extend outward. The adaptive mechanism is quickly adjusted to the simulated seating position. The stabbing motor drives the filter to rotate so that the single seed drops down to the container. When a double germination status is recognized, the servo drives the end factor to rotate and leave marks on the white paper were wrapped at the root of the plant to represent its removal. Due to the mistakes in recording video and in accordance with the principle of fair play, we place additional timer below the video to correct the error.
Okay, stop.
The scores obtained by the robot, as well as the status distribution table and population density, are shown in the figure. The total price of our robot is $160.18. Our instructor is Mr. Ye, who majors in agriculture, electrification, and automation. He gave us help and guidance when we encounter difficulties. Team member Jichun Wang is responsible for the main program code and the subsequent debugging. Team member Mengyuan Chen accomplished the integration of the thesis and participated in the debugging of the real car. Team member Jintao Feng finished the design of the major mechanism and the construction of the real vehicles. Team member Mengqi Zhang took part in the integration of the thesis and video dubbing. Captain Youchao Zhang realized the vision system and the auxiliary mechanism design. Other members are junior students who major in agricultural engineering. Finally, we want to thank the ASABE organization for providing us with this precious opportunity. In such a severe situation, you can still overcome many difficulties and ensure the normal holding of the competition, which enables us to cooperate and solve problems together. Every member in our team has gained an unforgettable experience. Let us work together to promote the development of agriculture.